So for today's deep dive, we're going way, way back. We're talking 1642 France.
Right. And at the center of it all is a 19-year-old kid, Blaise Pascal.
And our mission here is pretty clear. We're not just looking at some antique box of gears. We're tracing the direct line from this machine to the phone or computer you're listening on right now.
It's the classic story, really. A teenager sees his dad overworked and just, decides to invent his way out of the problem.
And you really have to understand the problem to get why the invention was so revolutionary. We're talking about 17th century French accounting.
Oh, it was a total nightmare. His dad wasn't just adding and subtracting. He was working with a currency system that, it makes zero sense to us today.
Yeah, I was looking at the notes. It wasn't base 10. You have the leave, the sol, and the denier.
Exactly. And the conversions are just bizarre.
So one lever is 20 sols.
Okay.
But then one sol is 12 denier.
Right. So imagine you're a tax official. Your brain is constantly having to switch between base 10, base 20, and base 12 for every single transaction.
The mental fatigue alone must have been incredible. The room for error, huge.
And that's what Pascal builds this for, this shoebox-sized brass box. You input numbers with a stylus, kind of like an old rotary phone.
But the real magic, the big technical leap, wasn't what you could see on the outside. It was all happening inside. It was how it handled the carry.
The carry is always the biggest hurdle. I mean, making a gear turn another gear is easy, but getting a gear to flip from 9 to 0 and kick the next one over, that's the hard part.
On an abacus, your brain does that work.
Pascal had to make brass and wood do it automatically, and that's where he came up with the sautoir.
The jumping device.
The jumper. It's such an elegant solution, it literally uses gravity. When a wheel turns from 9 to 0, a little weightage claw just falls.
And it kicks the next gear forward one notch.
By exactly 36 degrees. And the beauty of it is, because of that gravity assist, it took the same amount of physical effort to calculate 6 digits as it did to calculate 2. The machine did all the heavy lifting.
But it was, version 1.0. And it had a pretty massive limitation.
A huge one. The gears could only turn one way, forward.
Which, for a tax collector, is a bit of a problem. You had to subtract things all the time. Debts, refunds. So how do you subtract if you can't turn the gears backward?
And this is where it gets, almost spooky in how it connects to modern computing. He used a concept called nines complement.
He found a workaround. He basically turned subtraction into an addition problem.
He did. The display wheels had 2 rows of numbers. So to subtract, say, the number 2, you would instead add its complement, 8. The gears would turn forward, and because of how they're calibrated, they land on the correct answer.
It's mind-bending. And for anyone listening who's into computer science, that is essentially how binary systems handle negative numbers today with 2's complement.
He figured out a core data processing algorithm 300 years before the transistor even existed, and it worked. The sources say it cut calculation errors by over 80%.
It was so effective, King Louis XIV gave him what was called a royal privilege in 1649.
Which was basically the world's first patent for a calculator.
But the impact wasn't just, better accounting. It was philosophical.
Oh, completely. Pascal himself wrote about this. He said the machine performed a task that was, and this is a quote, closer to human thought than animal behavior.
That's a huge moment. It's the first time someone is realizing that a function we consider thinking calculation can actually be separated from the human brain.
It split the idea of processing from consciousness. And even though they were fragile and expensive, only about 20 were ever sold, the lineage is just undeniable.
You can draw a straight line from Pascal to Leibniz adding multiplication, then Babbage, all the way to silicon chips.
It just perfectly frames where we are now. We started by mechanizing arithmetic.
Now we're mechanizing art, writing, strategy.
Which I think leaves us with the real question to chew on.
Right. If a teenager in 1642 proved that a core part of human mental work can be done by a box of gears, what part of our thought do we really think is safe from being mechanized next?
That is the question.
That's it for this deep dive. Thanks for listening.